On Johnston Island, missile preparation for the July launch of the Starfish prime shot was one aspect of an extensive team effort. Close to the Thor launch area were a number of tracking stations, including the Pacific Missile Range ship, the USNS Range Tracker, all set up to keep an electronic eye on the missile and its warhead after launch. The bulk of the activity associated with Starfish Prime was the array of scientific instrumentation organized by AEC and DoD laboratories. Installations were crowded on Johnston Island itself, at sea, in the air, and at stations established throughout the entire Pacific area to measure the widespread detonation phenomena from the 1.45 megaton weapon set to burst 400 kilometers high. This far-flung array was pointed solely toward seeking the answers to several objectives vital to the nation's defense needs. Of urgency was the requirement for an evaluation of the effectiveness of nuclear detonations at high altitude for killing incoming ICBMs. This, in turn, would indicate the relative vulnerability of United States ICBM reentry vehicles. Equally important was the need to know the effects of high-altitude nuclear bursts on military command and control systems which require long-range communications. Another must was the ability to detect incoming ICBMs through high-altitude detonation environment for both defensive and offensive applications. One more answer was needed. How feasible was it to test nuclear weapons in outer space? To secure the data for these objectives, a variety of instrumentation was used, such as electromagnetic and optical equipment on the ground, on ships, and in highly instrumented aircraft to measure the production and spread of ionization and radiation. A number of special communications networks crisscrossed the Pacific. Many rocket payloads were prepared for firing into and around the weapon detonation area to obtain data on the fundamental physics of the burst phenomena. Specially designed pods were engineered to be attached to the Thor missile and deployed to pre-calculated positions from the burst. These pods contain different reentry vehicle materials, as well as numerous impulse and X-ray measuring gauges, each item located to obtain data concerning reentry vehicle kill mechanisms. 4 synchronized transmitting and 8 receiving sites operating in the high-frequency band measured effects on worldwide communications. Existing military operational communications links throughout the Pacific area were turned on to determine the disruptive effects of this detonation. Extensive radar measurements on shore, ship, and aircraft were made throughout the entire Pacific area to study the effects of military interest produced by the burst at various operational frequencies. As missile, tracking stations, and projects reported their readiness on shot day, the final countdown continued toward H hour. By noon, personnel non-essential to the island operation during the event were evacuated to the aircraft carrier Iwo Jima. The scientific readiness team made its final report, while the launch crew carefully monitored the last checkout. Starfish Prime was ready. The missile lifted off and began its long programmed trajectory. Now the scientific rockets were sent aloft, each carefully timed to be at an exact point in space at detonation. At its 1,100-kilometer apogee, the warhead arched over and dropped to its prescribed burst height of 400 kilometers.